Hello. Hello.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Screen દેખાય છે ને હવે?
हाँ
Yes,
सर.
sir.
हाँ सर.
Yes,
Okay.
sir.
Now, so today we'll start with the most important point, like dot convention in couple circuit. Now we know that last time in last lecture also we have discussed regarding the magnetic circuit. Now when we say this two winding, now when we say these two winding are connected, this winding number 1, that is N1, and winding number 2, that is N2, both are connected magnetically. Means whenever current passes through this winding, EMF is induced. That last time we already discussed that phi is equal to N into I, that is MMF, number of turns, that is suppose N1 here and here is N2, so N1 and N2, N1 and N2, like this N1 and I1. So N1 and I1 divided by reluctance of the magnetic circuit, that is the flux. That flux produced by, suppose I am saying that flux 2 1, that is flux phi 2 because of 1, flux link with the 2 winding because of the current passes through in first winding. So we can say that whenever flux link with this winding, and because of this Faraday's law of electromagnetic induction, that E is equal to N d phi by dt, N d phi by dt, d phi by dt. That means the number of turns N is N2, N2 d phi by dt. EMF is induced in the secondary winding between these two terminal. EMF is induced, that is E2. Suppose this is E2. This is E2. Now the same flux linked with this winding, that is E1. Here also one EMF is induced, that is E1. That E1 is equal to N1 d phi by dt. Phi 2 1, that you can say that phi is equal to phi 2 1. I can write this phi 2 1, or I can write phi flux produced in this winding. Right. Now this EMF induced in the secondary winding, which is always oppose the cause it produced because of Lenz law, that you all are familiar with this Lenz law circuit. Now the Lenz law, that we can say that this Lenz law is is such that EMF is induced in the circuit Okay, that means EMF is induced. Now here we can say that EMF, there are four EMF, two EMFs. One is the voltage, first of all, that is applied voltage. EMF induced by its own winding, that is known as self-induced EMF. EMF induced in the secondary winding, that is known as mutual induced EMF. And here is the voltage V2, that is known as terminal voltage. Means there are four voltage, that E1 and E2 are induced EMF, and V1 is the supply voltage, and V2 here one more terminal voltage, that is V2, that is known as the terminal voltage, because some of the resistance of this winding, because of some of the resistance in the winding, some voltage drops, that E2 is V2 is equal to E2 minus some drop because of this winding. Now the question is, when we applied the voltage, what is the direction of the current? Suppose here is the entering current. So what is the direction of the current in the secondary winding? That depends upon the EMF produced. That also depends upon the winding, how you wind the this winding, how you wind. Suppose this winding, you can observe it starts from upper side and goes downward, then upper and downward, and like this. Here this starts from lower side, then upper, then lower and upper and lower and upper. That means because of the winding position change, the EMF is also change. So to relate with this first winding with the second winding, we have to put dot. That dot is equal to the direction of the EMF induced. If both dot are equal in position, suppose here the dot is at starting point, that is entering, and here dot is say ending point, then we can say that both are in opposite direction. If both, here is the dot at starting, that is entering end, and dot is suppose entering end also, so both are the same dot, so EMF induces positive. Now I will explain in detail, so don't worry about this. So we can say that this direction of the current, depending upon the direction of the current, flux is produced in the core. This is known as core. This part is known as core. That is core. Means this both winding are connected with the magnetic circuit. That magnetic circuit, that is the core winding. Right. Now, how can we put the dot? Randomly we cannot put the dot at these and this point. There is some rule to put a dot, and it is very simple circuit. That very simple explanation I will give it to you, because this is a very simple problem. But if you don't know the fundamental or how to put a dot, then you cannot solve this problem. And it is very easy problem. It may be asked in an examination also. So it is very easy to get mark once you know the fundamental. So today's lecture, that based on the dot convention only, I will explain in detail how to put a dot, and then after how to write a equation using this dot convention circuit. So first of all, I will just give an example. Suppose this is one circuit, right? देखाय છે ને બરાબર? Hello.
हाँ सर.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Now this is, you can see that this is the transformer, simple transformer, three-phase transformer. Here one winding, this winding is N1, the second winding is N2, and this, and suppose this is first winding, the second winding, and this is third winding, right? Now this winding, you can observe one more thing, that this winding wound from this side, goes down, up. You can see the position of the winding, right? Here the winding starts from upper side here, then down and up and down. The dot is not there. The direction of current is not given to you at starting. You have to put the direction, and you have to relate this winding with this winding. Means how these two windings are mutually coupled. It may be opposite, or it may be in the adding criteria, or it may be the subtracting criteria. So same this winding for the same winding. Now if you want to put a dot, say example, this is our first winding, that is N1. We have to relate this one winding with second winding, one winding with third winding, and second winding with third winding. Right, means here one winding which connected first winding related with the second is mutually coupled with the third, second which is mutually coupled with the third. The question in your mind, that why we cannot connect 3 to 2 and 2 to 1, because both are same. Suppose you are saying that 2 to 1, it is same as 1 to 1 to 3, 3 to 1, that is same as 3 1, and 2 to 3 or 3 to 2, both are the same. So how will we put the dot between 1 and 2? So at present, when we put a dot of any blank circuit, so we have to consider one is the entering, one is the leaving end, right? Suppose I am saying that this current is entering from this side. Suppose current is entering from this winding. So you can observe this is the right hand. You can use your right hand position, like I'm just zooming this so you can see more clearly. Now we can see here, this is the right hand right hand with the thumb, which shows the direction of flux. This thumb shows the direction of flux. That is flux direction. Flux direction. Direction. Right? Flux direction. And this finger, that first, second, third, these all fingers are shows the direction of winding. Suppose this is finger which shows the direction of winding. Suppose this first finger it comes from upper side and goes downward. Here is also same case. It comes from upper side and goes to downward. It comes from upper side and goes to downward. Comes from upper side and goes to downward. So this is, you have to, what you have to do is you have to first put your hand, right hand, in the such a direction that will show the flux direction. Suppose this is the current, same we have put a thumb like this, we have put a direction, our right hand in this position. So we can say that the current passes through here, current passes through this winding, because this winding connection and your hand position both are the same. So if both are the same, then you can say this is the entering end, this is the entering point, and this is the leaving point. By chance, this winding is not same as your hand. Suppose winding comes inside this. For example, suppose this is the coil like this, whatever I have shown here. Suppose the winding is like this from inside and it comes out, inside and comes out. Instead of this winding, suppose winding is this, and if you put your hand here, then what happened? Your hand position, that is your first finger, indicates the direction of the current comes from one upper side, goes downward, then comes upper and goes downward like this, right? And finally it comes out. But in this direction, what happened? It is something different. You can see this is something different. Your hand position, it says that the winding should be from upper side. Here the winding should not be up from upper side, it is downward. So your hand position, right hand position, and your winding position is different. Suppose it is the same position, we can say this is the entering end, this is the leaving end. But if the position is different, then we can say this is entering and this is leaving. Instead of this is entering and this is leaving. And flux is the direction of the thumb. That means because of current passes through in the winding, the flux will flow like this, from this to this third winding, and from second winding to this winding like this. So whenever we put a flow of current in the first winding, it will produce a flux phi, right? This is flux phi produced. That flux phi link with this winding and produce EMF. This flux link with this winding and produce EMF. This flux link with the winding and produce EMF. That we have already explained in our first circuit. That circuit I already explained. Now, what is the question is, how can we put the dot? Suppose I put this first dot, because there are 3 winding, so I put the different dots. Suppose this is the red dot. Have you observed this red dot? So red dot, which is connected with this winding, second winding. This red dot connected with the second, because here is also red dot. So how can we put the red dot in the second winding? So we know that this flux passes through, first flux passes through this winding like this. Now whenever current flux passes through the winding, EMF is induced in the direction, right? So in EMF is induced in such a direction that always it opposes flux which is given by the first winding. So this green arrow will show the flux produced by the second winding. So we have to produce flux in such a direction that it opposes the flux produced by the first winding. तो आपको क्या करना है, that उसको thumb कैसे रखना पड़ेगा, right hand thumb the thumb है, that you should make in this position, and that is why the flux is in upward direction. Suppose you want to produce flux in downward direction, then you have to rotate this right hand in such a way that the flux, the thumb shows the downward direction, right? So I can say that this flux direction, so this thumb, this hand position shows that the winding, the position of the winding is such that it should be from upper side. So if this winding, it is same as your hand position, then you can say that this is the entering end So the first finger is the entering and last finger, this is the leaving end. This is the leaving end. This is the leaving end. Like, okay, so this last finger, your last finger is leaving, and this is the entering end, right? So your last finger is indicates leaving end, and this first finger indicates the entering end. If the position of the winding is if equal is same as your hand position, right? Now we can observe here, if we our hand position says that the winding should be like this. Suppose I am drawing this winding in this way. The second winding I am drawing here. So winding should be as per our hand position. The winding should be like this, like this. It starts from upper and down leave from the lower side. But this winding is not same as our requirement. It is something different. This winding, if this happen, if the winding is in this position, in this fashion, same as your right hand, then you can put the leaving end. Where you have to put the leaving end? At the last finger. Last finger means this position. At this position we have to put the dot. But the winding is not same as this thumb, this right hand. So what you have to do, you have to put a dot in opposite direction. If this position is there, then you have to put the dot here. You have to put the dot here, right? If the winding of second winding is the same as our hand position, then we have to put a direction. We have to put a dot here, because here is the entering, so here is the leaving, right? But the winding is not same as per our requirement, as per our hand. So what you have to do is, we have to put a dot in opposite direction. If in actual position it will the same as our hand position, your dot must be here, right, at my cursor position. But it is not same as our requirement. It is something different. But our aim is to produce flux in this direction only. So to put a hand in this direction, if it is the same, the winding is same as the hand position, your right hand position, then you have to put dot here. But it is not same, then you have to put in opposite direction, opposite end. Right, so that opposite end, it is the leaving end. Like I have shown this leaving end. So this first dot, which is related with the second position. समझ पड़े छे? हेलो हेलो
Yes, sir.
समझ पड़े छे बका? Got it? नहीं? हेलो?
Yes, sir.
हाँ चलो, what is the question?
સર તો સવાલ એ છે કે વાઇન્ડિંગ જે છે એમાં અંદરથી બહાર કે બહારથી અંદર એ વાઇન્ડિંગ ની પોતાની ડાયરેક્શન છે કે એમાંથી પાસ થતા કરંટ?
That will be the winding the direction, that is the current passes through. Suppose you are winding in this direction, the current will flow like this, right? Suppose winding in this position, the current will flow like this. That means the winding, એટલે કે જે વાયર્સ તમારો જે છે વાયર, એ તમે કઈ રીતે વાઇન્ડ કરો છો એના પર કરંટ ડિરેક્શન ડિપેન્ડ કરે છે. હેલો, સમજ પડી કે નહીં? હેલો, ગોટ ધ પોઈન્ટ, રાઈટ? એટલે આપણે શું જોવાનું રહેશે કે when your current direction, your hand position and your winding position both are same, then you have to put dot entering at first finger and leaving at the second finger. So we have to relate our first winding with the second winding. First is entering, so second માટે આપણે શું જોવું પડશે? That we have to observe leaving end. So leaving end means the last finger. તો આપણે dot અહીંયા મૂકવો પડે. If your winding is not same as your required hand position, then you have to put your dot in the opposite direction, right? Now the same for 1 2 3. Now we can observe 1 2 3, right? So you can practice at present also, you can practice with your hand. Suppose this is our second dot. That dot, different dot we have to use for the this is for 1 2 1 and this is 1 2 3. So 1, that is entering point, the flux will flow like this. Now what is in this position? Your hand, you have to put a hand like this. because our aim is to produce flux in upward direction, right? So upward direction માટે તમારે how you can you have to put your hand in this position. So when you put this in this position, so your winding should be from inside. You can observe that this is our outside portion. The winding it from inside the turn and it comes out, then inside and comes out. Right. That means if you wrap your hand in this winding, इसको अगर आप पकड़ लोगे, इसको आप पकड़ लोगे, so that is the position of your finger will show the position of your winding. Got it? Your position of the finger, that will be your position of your winding. You have to wrap your hand around this position. આ જે છે સેમ અહીંયા તમારું અંદરની સાઈડ છે તમારું વાઇન્ડિંગ છે એવું સમજી લો, કોર છે એવું સમજી લો. તો તમે when you use this thumb in such a way, so how can we say? We can say that if this position will show that winding from inside at starting, that will be okay, and comes out, because this will show this finger, this finger and this finger both are same, right? This is position, and again winding goes down, then come out, that will be shown this direction, right? So your last finger, this is your last finger. Your last finger will show the out current, and first finger will show your input current from this side. This will show the input current and this will show the output current. Now we have to relate our input current of the first winding with the out current. If what I have explained, that your hand position, your hand right hand position and your winding position both are same. So your first finger will show the entering and last finger will show the out of the current. So we have to relate incoming current to the outgoing current. So this both position are same. Here the both position is not same. So we have put dot in opposite direction. Actually कहाँ पे आना चाहिए? लास्ट फिंगर में आना चाहिए, लेकिन लास्ट में नहीं करेंगे हम लोग, बिकॉज वाइंडिंग इज समथिंग डिफरेंट देन योर पोजिशन. सो हमको यहाँ पे रखना पड़ेगा. नाउ द सेम हियर, where we have to put the dot here outside last finger. We don't have to put opposite, because this hand position and your winding position both are the same, and that is why we have to put the dot in this direction. So that is the relation between 1 and 3. Now 2 and 3, I have to put 2 and 3. Now 2 flux will flow like this. This is green. That green means the flow will like this. Flux flow. Flux produced by the second winding will flow like this and will flow like this. So I have to observe 2 to 1, 2 to 3, sorry, 2 to 3. So 2 to 3 means this is the flux passes produced by the second winding, and I have to produce flux in opposite direction. So same position will comes into picture, same position. So here is the leaving end. What we have put a dot here is at entering. That hexagonal dot at entering. So where is the hexagonal dot at leaving end? Leaving end is in same position of last finger. Entering end, here is the entering end. We have put entering here because this is the leaving end. We have observed that this is leaving end if you want to produce flux in this direction, right? So this is entering, this is leaving. In this way, we can put a dot like in our dot convention. Now what you do is, now you practice this. I will give you 5 minutes, 5 to 4 minutes. You just practice it, and then I will give the answer how to solve this, right? So whatever I have explained, I am just zooming in so you can observe both the circuits. Now this winding 1, 2, 3, 4 and 5. So what you have to do is, you have to make 1 to 2, 1 to 2, 1 to 3, 1 to 4, 1 to 5. Then 2 to 3, 2 to 4, 2 to 5. Then 3 to 4, 3 to 5. Then 4 to 5. Means 10 combinations are there to observe. Suppose, so we have, first of all you have to relate 1 with 2, right? I've just give the direction is like this, suppose. So this is the entering. So we put a dot entering here. First one dot. Suppose you are putting the square or round dot. For the third winding you have to put the square. Fourth winding you have to put a triangle. And fifth winding you have to put another angle, another dot, different dots you have to put. Now normally in examination only 2 or 3 winding may be asked in examination, but I have given for the practice it is 5 windings I have given, right? So first of all, one winding, suppose you just write down your position, you just put your hand position in this direction, you have to wrap your hand on the cord, so you will find the direction of the winding, right? So you practice it. I will give you the 5 minutes, then I will start the answering, then you compare your answer with the my answer. Okay, તો પ્રેક્ટિસ કરો તમે લોકો 5 મિનિટ આપું છું તમને, રાઈટ? હલો હલો હલો.
Yes, sir.
અચ્છા, હવે મારા સાઉન્ડને કોઈ અડવું નહીં, હા, કારણ કે અહીંયા મ્યુટ થઈ જાય છે, એટલે મારા સાઉન્ડને તમે રાખજો ચાલુ. ઓકે, એને કોઈએ મારા જે છે એમાં તમારે સાઉન્ડને મ્યુટ કરવાનો નથી કોઈ. ઓકે, કામ કરીએ આપણે. we'll discuss this problem in our next lecture, right? You just try it yourself, then we'll go for the next point, that is also important point. બરાબર છે? ઓકે, આ તમે પ્રેક્ટિસ કરી લો, then we'll discuss in next lecture. ઓકે,
ઓકે સર.
હા, એટલે પ્રેક્ટિસ તમે કરી લો આની, પછી આપણે ડિસ્કસ કરીએ છીએ તમારી રીતે. પછી સમજણ ના પડે તો આપણે ક્વેશ્ચન નેક્સ્ટ વીકમાં કરીએ છીએ, રાઈટ? સોલ્વ. Now I have to take an example. Some example I have taken here. Sound mute करो तुम्हारा, कौन चालू है? Now this is a simple example. I have to put a dot. This is that example already we have solved here. The same example, but it is something different. The dot position, the winding position is something different. So you can put the dot. Suppose here one dot we have put here. Now the problem sum, it may be asked in this fashion also. Now we know that the example I am just taking one example, that put dot in figure shown below, write the Kirchhoff's voltage law equation for this network. So sometime this whole network is given to you. Now here I have already at present I have relate the entering point to the leaving and entering to the leaving we have already link entering with the leaving, but sometime dot is given to you, dots are given, so you have to dot is given, and according to dot given dot position is given, you have to write down the equation. Now before we write the equation, I will just give 2 points that you have to note. That first point, if the dot position of both winding is same, it means that the dot entering is connected, it is related with the dot entering to the second winding. Entering with entering, if the same, you can take a positive EMF induced. Positive EMF, right? If the dot position is not same, not same, then you can take this as a negative EMF. I will explain in detail. That is EMF, negative EMF, right? That means if the dot are, suppose dot of 1, for example, here the dot shown here for the first winding relate with the second winding, and current direction is also given. So we can see that this entering, here is the entering point, dot is entered, a dot at entering point, and here what, this is not a dot, this is some mistakes I have made. This dot related with this dot, so this is entering and this is leaving. You can observe this 2 point, this dot and this dot. This is at entering, this is at leaving. So we can say that both are in different. So we can take the negative EMF, because we know that when EMF is induced in the inductor, there are 2 types of EMF is induced. One is self-induced EMF, which is given by L di by dt, right? L di by dt. And second is the mutual induced EMF, that is mutual induced EMF, it is given by M di by dt. Right, M di by dt. There are 2 types of EMF produced. So suppose we have one winding L, then we have 2 types of EMF. One, in this case, we have induced EMF produced by this self-induced inductance L1. EMF is induced because of current passes to second winding, that is mutual induced EMF, and induced EMF because of the third winding into first winding. Means there are 3 EMF is produced, one because of self, second because of L2, and third because of L3. That 3 EMFs are induced. So we have to write the equation for third. So from this figure I have to draw an actual figure. That is the same figure I have drawn here. You can observe that this R1, this winding L1 I have shown in symbolically. This R2, that circuit is closed now. Second winding is connected from this L2. There is no other component. Third one, that is inductor and capacitor, that circuit I have drawn here. Right. So from this core, this actual winding diagram, I have converted into the wiring diagram of the circuit. That also you can put in this way also. This is given, and you have to write the equation also, right? So this is most important point. You just listen carefully. So we can see that here when we applied the voltage, there are 3 loop current we have to assume. Here there is no loop current is given. We have to assume the loop current like this, I1, I2 and I3. Now when you assume the loop current, accordingly you have to write the equation, right? Now we can observe one more thing, that current in this inductor, what is current in this inductor is I1 in this direction and I2 in opposite direction, right? So current in L1 in between, this is a common inductor. So I1 minus I2 for one loop. Second loop here, what is the current is I2 minus I3, current in this only I3. There are 3 currents, and dot I will place as per dot given in the actual circuit. Now I have to write the equations, EMF equations. So for writing the EMF equation, I have put a circuit in this case. Suppose this is R1 as it is. Now I put one circle which shows the direction, which shows the EMF induced by a second winding. Now M12, that means mutual inductance of 1 because of current passes through the 2. Second, mutual inductance of 1 because of current passes through 2. So whenever current passes through the second winding, it will induce EMF in first winding. That is this EMF. This is M12 di by dt. What is current in second winding? Current in second winding, which is equal to I2 minus I3. This is I3, no? I2 is not I3, it is I3. This is L2, sorry, this is L2 and this is I3, current I3. So what is this current in the second winding? Now what is EMF induced in first winding because of second inductor? That is given by M12 di by dt. So d instead of I have to write I2 minus I3 because in second loop in inductor, what is current passes to inductor is I2 minus I3. Now the question in your mind, why not I3 minus I2? Because we have to look after second loop. Second loop means we have to take I2 is positive, I3 is negative. Now if you look to say third loop, then we have to take third I3 is positive and I2 is negative. That we will take in this way. So in this case I2 minus I3, this EMF is induced. Now the direction is most important. I have put here positive and I have put here negative. Why? Because we know that I1 current will flow like this. I1 current means current in L1 that equal to I1 minus this current in L1 but equal to I1 minus I2. So this I1 is positive, then I2. So we can say that resultant current will flow in this direction. So resultant current will flow at dot point, means at dot point current is entering. Okay. Now the same point, what is current in inductor? Current in inductor is I2 minus I3. So resultant current will be in the direction of I2, that is in this direction. So this current is also entering at dot point, right? That means this resultant current in one loop is entering at dot, entering at dot, and here the dot at entering. In the both the position, your dot at entering point. You can see that here I1 current in this first loop, that is at dot at entering point because current entering at dot. Here is also current entering at dot. Both are the same position. That means upper is plus, here is negative. Now in second, you just observe second, then you will find exact position. Now in second, I have not put plus or minus previously. I have to put first of all only the circle. Now this is the EMF induced because of the third winding. Because of third winding. Now current entering at first winding at dot point. Current entering at dot point, means dot, we have placed dot at entering of the current in first winding. Now what is current position? Here I3 will entered in this direction and leaving at this position, right? So where is first dot? That is triangle. This triangle is related with the third winding, right? तो यहाँ पे triangle कहाँ पे है? Entering में है, right? This triangle is entering, while here current is leaving at triangle. Current is entering at triangle because of resultant current at entering at triangle. Here resultant current will leaving the triangle, means both are different. Here is entering, here is leaving. So this upper terminal is negative, lower terminal is positive. And this way that position or the terminal, the polarity is reverse, negative polarity. Here the polarity is positive polarity. So this is now the second case. Now you just observe the second case and you just mark polarity in your mind. I have marked plus here and negative here because this is the voltage. the second winding, right? Now the second winding means the voltage, because that is known as M21. M21 means the mutual inductance of 2 with the help of current passes through 1. What is current passes through 1 is, because I am looking to one loop, that is I1 is positive, so I1 minus I2. So M21 di by dt I2 minus I1, because current passes through in first inductor, that equal to I1 minus I2, right? So now here is also dot, you can observe dot at entering, here is dot at entering, so both are equal, this positive and negative. Now the second M23 means the EMF induced in second winding because of third, current passes through third winding. What is current passes through third winding? Only I3, right? And here you can observe that current passes through the second winding, which is leaving. We have to observe the dot here. This is a square dot relate with the square dot. So current is leaving here, and here is also current leaving at dot. Current leaving at dot, leaving at that, both are equal. Leaving, entering. Then we have to take plus here, minus here. Plus here and minus here. If the dot related to the both the winding are different, then we can observe that it is not the same as our requirement. I have already given the dot are the entering and entering or leaving and leaving, we have to take positive, upper terminal is positive. If the dot are not same, suppose entering with leaving or leaving with entering, then we have to take the negative. Right. For the same, for the third also, you just take your own, put your polarity with your own by explaining this. So in this way, we can put the dot, and then after we have to write the equation. Then we have to write the equation also here. So I will write equation in next lecture because time is up now. So you got the point or not? Any students? Hello?
Yes, sir.
You got the point? Means entering and entering is positive, leaving and leaving is positive, entering, leaving is negative, leaving and entering is negative. Okay?
Yes, sir.
Yes, sir.
समझण पड़ी કે ના પડી આ લેક્ચરમાં? હેલો?
Yes, sir.
એટલે હવે છે ને મેં તમને જે પ્રેક્ટિસ માટે આપી છે ને, that you have to clear, that is the practice I have given, and then after you just practice yourself and write down the polarity. પહેલા તમારે અહીંયા સર્કલ મૂકી દેવાના આ રીતે. Then after plus minus, અહીંયા પ્લસ ઉપર મૂકવાનું if both are the same direction, and here we have to put the negative if both are the negative direction, both are the opposite direction, leaving, entering, leaving. So you can put your dot using this method, that you have to first to practice this. Then after you have to write the equation also. Means there are different types of examples asked in the GTU exam. Now one that you put the dot first of all. This equation is, this circuit is given, you put a dot only, you will get the mark. Then after dots are given, you have to write the equation. And one more method, that this circuit is given, this circuit is given, you have to draw this circuit from this circuit. This circuit is given, and you may ask that find out what is the actual core circuit, core in this. You have to convert this circuit into this circuit. So in this way, we can put a dot and find out the value, right? Now I am just taking the attendance, so please don't leave now.